the most fundamental scientific question of all time: how were the planets and our solar system formed? Vital clues can be found in meteorites, which contain information stored for millions of years. At the Open University in Milton Keynes, Britain, a meteorite expert from the Earth Sciences Department, Dr. Phil Bland, believes he might be on the trail of discovering a new large meteorite impact crater. His trail began several years ago when in 1992 an American scientist, Professor Peter Schultz, published a paper in Nature magazine. Schultz had discovered a unique series of crater-like features in Argentina. In the features he found fused rock and soil, evidence of a meteorite impact. Schultz concluded that a meteorite must have entered the Earth's atmosphere at a low angle and then skipped across the surface like a bouncing bomb, gouging out the craters and depositing material in them. British scientist Dr. Phil Bland is now challenging Schultz's theory. He thinks that the elongated craters have been caused by nothing more than wind erosion, exposing meteorite material which he believes has been deposited not from a bouncing meteorite, but from a separate single impact. To prove his theory, he must now find the original impact crater hidden in the Argentinian pampa. 10 years after Schultz first published his theory, Phil is returning to Argentina. If Phil's right, the crater he hopes to find will be buried and well preserved. It would be a significant find in meteorite exploration. Phil arrives in the small town of Rio Cuarto, in the heart of Argentina. He has just 10 days to gather enough evidence to prove his theory is more likely than Schultz's. Whilst in Argentina, Phil will be helped by Brazilian scientist Carlos Roberto de Souza, by Argentinian geophysicist Dr. Lucio Pinotti, local geologist Hugo Schiavo, geomorphologist Jorge Corniglio, and geology student David Chondwant.
In 1992, Pete Schultz, who's a professor at Brown University in the States, published a paper in Nature which described a whole bunch of elongate scars in the pampa, these things. And he thought that they were made by the low-angle impact of an asteroid that came in and hit and bounced as it was slowing down. We started to discuss it with some of the local Argentinian geologists. And for a long, long time, they've thought that these features were actually made by the wind. As you can see today, all the wind's blowing that way. And all of these things are oriented in this region, north-south. We found meteorites in these features. And it's interesting that the ages since the meteorite's been on Earth is much, much longer than the time that the features have been here, which didn't make any sense to us because those meteorites would have been taken away by an impact. So I started to think that although these features are really interesting, they couldn't really be made by an impact in the way that Pete Schultz had thought.
Phil's challenge is not only proving that Schultz's features are just wind erosions, but that the meteorite material found in them has come from a separate single impact elsewhere in the pampa. Phil starts his journey at the University of Rio Cuarto to meet local geologist Hugo Schiavo, an expert in the area's wind directions.
And see what he has to say, yeah, about the direction of those things and if it's the wind features. So.
Hello. Hello. How are you?
Hello, Hugo. Nice to see you, mate. Excellent. So what we want to do is get some idea for why the direction of these elongate features changes throughout the region, why there's so many different directions. In the north we have kind of north-south. And in the south, they curve more like north-east, southwest. Yes. Is that similar to the wind direction in these areas? Does it also change?
The compound direction is changed.
Okay. Okay.
To the south province, in this side, the orientation of winds change
A little bit.
If the direction of the local winds is the same as the orientation of the features, it will go a long way to proving that they are indeed just wind erosions and not, as Professor Schultz had surmised, meteorite craters.
northeast, east, northeast.
Okay, cool. That's great. No, that's lovely. Yeah, that would be lovely.
Hugo confirms that he believes the features have been caused by wind erosion. However, that doesn't explain the existence of meteorite material found in the features. Phil's theory is that a single large impact north of the features splashed glass southwards over the pampa. That glass is now most easily found where the wind has blown away the surface soil. Together with some of the local scientists, Phil visits one of the erosion features to collect samples of glass and meteorite material.
What have you got in the box? What is in the tin? What is this? Oh, sandwiches.
Tamis.
Tamis. Oh, tamis. Okay, okay. Cool. Ah, okay, excellent. I guess the idea is that somewhere in the pampa there's been a really big impact, and that splashed glass all over the whole region, over a huge region. And the best place now to find that glass is in places where the wind's blown all the soil away, because then we can just walk around and see it. Yeah, so that's another bit. Glass is fused rock, and it's mostly made of the target that the asteroid hits. So in this case, most of the glass is actually this soil. Meteorite is actually a rock from space, so that's part of some planet or asteroid that we get that falls to Earth. I think that's a meteorite. So it's got Hey guys, I think this is a meteorite. It's kind of heavy. Get that in there. So.
Yes.
Yeah.
Although relatively easy to find glass in the features, Phil's theory of the single large impact would mean that the glass would have been scattered for hundreds of kilometres all over the pampa. Phil must now try to locate glass as far south as possible in order to back up his theory.
So I'm going to go down south and look for some of the glass. Now the reason I'm doing this is because there's a colleague of mine called Natasha Artemieva in Russia, and she's got a great way of kind of visualising what happens when an impact hits the Earth and where all the glass goes. So we want to do that because then we can hopefully, get a sort of confirm that this might be a place where the impact happened. So this is what happens when a 500-metre object hits the Earth. So this thing comes shooting down, that's the top little layer of soil, and then hard rock underneath. This is all glass that's kind of shooting out the other side. So you can see you get this huge plume of stuff that comes piling out. And it's like a real turbulent thing. And that's going to go a hell of a long way. So we want to just find out where that goes.
Phil is heading south. If his theory is correct, the meteorite will have thrown glass hundreds of kilometres, and finding the glass will back up his theory of a single large impact. He drives 400 kilometres into the heart of the pampa.
Now, if our theory is correct, then we'd expect to find this glass from the impact over a huge region. Not just confined to near the crater, but over hundreds of kilometres. So we'd want to look around and try and map out just how far that is. Doing this is going to give us a feeling for how far the glass has gone and how big the crater is. So we're just looking for little bits of glass, and all it is just like this stuff, just soil that's been melted and kind of fused. So it'll probably be about button-sized and just a kind of fused, bubbly little rock, but it won't have minerals in it. It's like glass on your window, but it won't be clear. It'll be green or brown or something like that.
No luck here, but it's crucial that Phil finds glass this far south if his theory of the single impact is correct. He continues to look around the area, digging, sieving, searching, until at last.
I think it's a bit of glass. It looks bubbly and it's kind of greenish, but I can't see very well because I'm very short-sighted. But I think it's glass.
As ever in the scientific world, the more evidence, the better. So, still not satisfied, Phil continues searching.
So I think I found a bit of glass that's been washed out of this kind of cliff here. This is a lot like the stuff we find up north, so that's really great. I'm chuffed.
Finding glass this far south is further evidence of the single large impact. Phil's problem now is locating the crater, which in all probability will be buried under several meters of soil.
So the problem that we've got, right, is that the whole thing is buried under all this soil. So I mean, if the crater was in like perfect shape, it would look something like that. So you'd have like the rim coming down like that, and a flat base, and maybe a central peak in the middle where it's bounced, and a little raised rim at either end. But because we've got all this soil that's filled all of that in, it's like 50 odd meters deep. So it could be that we're really unlucky and it's just filled the whole thing in, and in which case we're never going to see it. But if it's a bit thinner, then we might get a kind of a something like that.
Spotting the crater from the ground is obviously going to be difficult, but Roberto has taken 3D satellite images of the area, which enables him to see the topography of the land.
Right.
Here the lakes.
Okay.
And the structure is like, you see this rounded structure here?
Oh, right,
By this
okay.
river.
Oh, okay, you'd like
Then
that.
have these radial patterns
Yeah.
coming out of a spot.
Right, in there,
It seems
yeah.
to be a high, right?
Yeah. Oh, that's a high, you think?
Yeah.
Really? Oh, wow. Are you okay, you think that's a high?
Yeah.
Because okay. Okay.
They are able to pinpoint an area which looks to be the likely spot for the hidden crater.
So if that is a high bit in the middle there, and around it is low, then that would be really nice.
Yeah, it's a little high. It's not that high as I thought in the
Okay.
beginning.
How big is the high bit, do you reckon?
Well, it's very tiny actually.
Really?
It's just around this black
Oh,
dot
really?
here,
Oh,
yeah?
wow.
Then everything just goes gradually.
And is this around it low?
That's right.
That's lower than
That's
the surrounding
right. It's
plane.
going lower towards the plane.
So what I mean is it like that and a peak?
That's right.
Really?
Precisely.
Wow. Okay.
Precisely.
Okay, that's really nice.
Believing they have pinpointed the possible location of the crater, the next task is to study the underlying rock structure of the target area, and in effect see beneath the surface and map out the crater. Phil has brought a gravitometer with him. This will enable them to record specific gravity around the area of the crater. But first, Phil must set the equipment to Argentina's local gravity.
When a crater is made on a planet, you've effectively taken out a chunk of the surface of that planet, of that crust, and that changes the gravity underneath it. You'll actually have a little bit less matter, so a little bit less gravity. But we found it. God for that. That's brilliant. So now the official gravity in Rio Cuarto is 2950.228. That's good. I mean, the nice thing is it'll let us we can work out what's going on under the soil, so we can see the crater, if it is a crater. At least we'll be able to say that much.
Meanwhile, Roberto, again using satellite images, has found another interesting aspect.
Can I have a look?
There are underground streams flowing towards the centre of the feature, indicating radial drainage, an encouraging sign of a buried crater.
A minute west of that. But I think, yeah, I mean, basically, yeah.
Phil, Roberto, and the team of Argentinian scientists all gather at the site they now believe hides the buried crater. But there's some bad news.
Decía yo, damos a los baneados lo que yo decía. Y porque el tipo nos dijo, hablamos por teléfono con el dueño, Hernando. Y el tipo nos dijo, adentro del campo no, si quieren por la periferia, anden por donde ustedes quieran, pero adentro del campo no.
Yeah. So we can't walk, but we can do the road.
Y la excusa es la tos.
You can do the periphery of the farm, but you
Okay.
can't go into the farm because of foot and mouth.
Right. Okay. Okay. So well, that's so we can do the roads. We can stay on the roads. Okay. Just means no walk, you know. But that's not so bad. So it turns out that the farmer doesn't want us to go on his land because he's very worried about foot and mouth. So what we're going to have to do, so it's a bit of a pain because last night we were all excited and we got a bit pumped up about coming out here today and getting into the middle of it. But really, you know, chances of us finding anything like a rock are probably slim, so it's not a nightmare. So we can do a lot of work here today along the road, maybe go a little explore in the cars. So it's a pain, but it's not, you know, end of the world. So if you just record the position and keep track, like, so maybe that's post 1, 2, 3, west, and then 1, 2, 3.
Yeah, I have like a few pens, make a tiny little mark.
Okay, mate, yeah. But keep, you know, as long as you've got it straight in your mind, and just, you've got a notebook.
Yeah.
Okay, cool. Yeah, no, I'm sorry. Yeah, okay.
Although not able to get right to the centre of the feature, the scientists set about gathering data from the surrounding area. As well as recording the specific gravity, they also record the magnetic field of the area, as a meteorite impact would have increased the magnetic strength of the underlying rock.
If we've had an impact in it somewhere, then that we might expect that would change the local magnetic field. We might see a feature there in the magnetics that can give us a hint that there's been an impact.
With readings from both the magnetometer and gravitometer, it's crucial to plot the exact location using the global positioning system. Readings are taken from the area just outside the crater and on a straight line towards the centre, crossing the supposed rim of the feature to give a cross-section of the underlying rock. The information gathered by Phil, Roberto and the team could provide compelling evidence of their theory. But first, all the data will need to be fed into a computer for analysis. Despite the disappointment of not getting to the exact centre of the crater, local farmer Adolfo makes amends by providing the team with a well-earned supper.
It's amazing. Wow. That's it, Adolfo. That's gorgeous.
It's been a good day's work, but only tomorrow will they know the results of their labour.
So you got the one
This is
going
like west to east
right.
section,
Okay.
which was like the most detailed.
Which we
We
did a bit when I was
together.
there.
That's right.
Great.
And, so you know, double check it.
Cool.
Data, everything.
And it
It's
stands
very
up.
consistent.
That's lovely.
And then we're on the next section, which is north.
So going right from going up from the south
South to
towards the
north,
north
that's
into the
right.
centre of it.
So
it shows the
we
centre
have like
of
one
the
section this way and another section this way.
Nice one, mate.
So
Okay.
it's almost like having a 3D
Yeah.
variation.
Right.
And the other one is pretty good as well.
Yeah, it is, mate. Yeah, that's
I really like
interesting
this
too.
one.
That's nice.
Yeah.
So let me see. So that's so at 2000, it's 3, 4, 1, 2, 2, 3, 4, 1, 2, 2. It's go back to the other one again. Sorry. Nice. It's nice that there's a. I like that there's a magnetic bit as well.
That's right. There are variations.
Yeah.
That's the way
Yeah.
mag data works.
That's cool, mate. This is great. And it's a bit more definite. I mean,
That's
instead
right.
of just like this might be more or less magnetic rock, we've got this is a hole in the ground kind of thing.
Yeah. Have 2 pieces of
I know
evidence.
what you mean. You see it somewhere else. That's neat. That's nice.
I'm quite happy.
Yeah, I think it's really nice, mate. I mean, that's way beyond what I thought we'd get. You got it? All right, let's go and see the other boys.
Sure. Let's go.
Roberto then translates the computer data for the rest of the team.
Here's the place where we did the section, approximate elevation along this section. would be something like, you know, meters distance. We have a high at the border of the feature, and as we come close to the center, a low, a little bump, another low, and a higher. So that's elevation data.
Yeah, I like
Gravity data is something like low. It's higher and higher as we go outside of the feature.
Okay, so that's going now. It's going from the inside.
Inside, this is like
Right.
the center.
Yeah. Okay. To the outside.
Okay, and goes lower,
Okay, slowly.
something like that. This is mag data.
That's nice.
Meaning that there is something which is more magnetic in the center rather than outside the feature. So this is like a cross section through the whole feature, like this feature here,
All the way across.
all the way across. And you know, there's this little bump here
Yeah.
that would you expect to
It's
have
interesting. In a crater on that of that size on Earth, it's big enough so the rocks kind of behave like plastic or liquid for a moment. So the thing hits, and they bounce and kind of rebound in the middle. So you can often get a peak in the middle of a crater if it's that big. If it's like 10 or 12 kilometers.
That's right. Very interesting.
It's nice.
Yeah. I believe we've got, you know, a nice list of evidence
Yeah.
that there's something special in this place here.
Right.
So I'm not sure what you think about.
No, I think you're right. I mean, this is what we'd see if it was a crater.
Yeah.
So it means that it's a place that we're going to have to come back to and do a lot more work.
It's Phil's last day in Argentina. Still unable to walk to the crater because of the foot and mouth, Phil and Roberto have hired a plane to fly them over the area. Will yesterday's encouraging data now translate into something more tangible?
Going up in the air and getting a look from much higher up is great, because then we can really see much more detail on the topography and get a feeling for where that buried crater might be. You can really see the rim of it, like really clearly. That's amazing. Look at that. Oh my God. Yeah, it is. Yeah, definitely, man. It's lovely. No, you got it. Yeah, you got it. This is much better than being able to walk in, mate. Yeah, this is great. Thumbs up. Yeah, that's really nice. We can see a bump in the middle. So that's just what we wanted to see. So it's just exactly what came out of Bert's stuff, and now we've confirmed it on the ground. Well, you know, from the air. This trip has really been a great success. I mean, not only have we, everyone's been really helpful and the team has worked really well, but we found really everything that we could hope to find. We found a meteorite on the first day, we found bits of glass, we found glass way down south, and Beto and Jorge have done a great job with the gravity and actually got a hint that we might have a buried crater. So it's been really exciting. It's been a great trip. The next step really requires a lot more effort, a lot more time, a lot more people, and a lot of money. So the nice thing is now is that we've got enough information so we can actually make a case to try and justify spending that time and money on really seeing, is this the buried crater?
The trip is by no means conclusive, but the team of British, Brazilian and Argentinian scientists have certainly gathered enough evidence to justify further exploration and to warrant a little celebration.
Hello. So, hola. Thank you.
Thank you.
Thank you
Gracias.
for everyone's help.
Okay. Gracias for.
So I hope everyone's had a good experience, a good time, a good time.
Una buena experiencia, un buen tiempo.
Lovely, thank you. Lovely.
Phil will need to return to Argentina to carry out extensive tests on the area, including drilling the rock that he now believes to be a new impact crater discovery. If he's right, the buried crater should be well preserved and will be a significant find that will help scientists worldwide to a better understanding of major meteorite impacts.